Hey, I thought I'd really quickly document what I've got set up here for my X-Carve. I don't have an ideal vacuum solution right now. I've got this little shop vac and standard hose. And then I have this attachment here, which goes into this mount, and then it's able to slide and lock to the side. Everything right now is a little hard doing one-handed. And anyway, slides and locks. Then I've got a pin mount here. This is on Thingiverse. This is on Thingiverse. This top cover's on Thingiverse. This is a scope and pin mount. I redesigned this based on someone else's design. This is someone else's design. This is someone else's design. Vacuum hose goes here, and the shop vac gets turned on. And there's an exhaust hose that goes along the back wall. Everything's standard to the new X-Carve model as of October, so it was like just released as far as October. Then I've got the X controller here, which I've done a good amount of customization to. It doesn't have the USB port on the front. It has a switch, if you can tell. And then I've got a IoT relay connected to the spindle PWM pin, and then everything else is pretty standard for the back of the connection on the X-Carve. You know, all the relay switch, or all the bump switches, limit switches, they're all there. And I'm going to show you real quick what I've done with the X controller. So I click on the X controller, and while it's booting up, I'm going to go ahead and open this up. Let's just show you over here. I'm using cnc.js, which is a web application, because I didn't like passing all of my information over the web for the CNC controller, because if I lost internet connection, my job would terminate, or if I lost network connectivity. So there's a lot of points of failure as far as the network goes. So I'm going to move this to the side. So what I've got here, and it's a little bit of a mess right now, but I'll go ahead and separate it out just a little bit. So I'll move this up to the top. Okay, so what I've got here, these two wires over here. This right here is a DC to DC step down regulator. So it steps to 24 volts for this power supply down to 5 volts. There's a potentiometer, this little silver button, or this gold button on the top. And you can get these just about anywhere. It's DC-DC converter or switch regulator. Very efficient. It's very cold. It's cold to the touch. And when it's running the Raspberry Pi, it still stays cold. This is a Raspberry Pi 3 inside of a acrylic case. And the only things I've got connected to it right now are power, a shutdown button that is activated by a Python script. So when I want to shut down the Raspberry Pi, I just click this. And I have another button coming that has LEDs on it, so I can see when the Pi is powered off and a few other neat tricks. I just don't have that in yet. Then it's got heat sinks on it. Not that it really needs it or will get any benefit of it in this case, but this is just a nice acrylic case. It gets held into place pretty good when the e-stop is installed. So I don't really have it screwed down or mounted really in any way, but it makes it nice and easy to get to. I have this USB cable just coiled up in here, which connects to the Gerbil shield, or Gerbil board more so. And that allows me to power everything. So it starts up really quick. Once it starts up, I start getting pings from it. And then I've got passwordless login set up, so I can come over here, start logging in. And I've also got a little strange script set up. And I can go ahead and run htop. And I've got some neat tricks in here so that, well, let me go ahead and exit. So the reason I like using screen is if I lose connectivity, so I can hit yes or just hit enter. I've got an update script that I can do to do basically just type update and it will update everything. What I really want to show you is the web interface for it. So I've got some designs I've done recently, and let's see, I'm not sure. I'll go ahead and load this little torture test it did. And I built this little torture test it's loading right now, and you can see the processing power that's required. It's only running on one core for running it, but it generally loads pretty. There it is. Okay, this was made in Meshcam with a model from Onshape. I prefer recently using this one, which is made by Kirimoto. So it's generated with Kirimoto, which is this web interface that'll allow you to do meshing. So I can slice it, and it will do a roughing, a finishing, it will do drilling. It doesn't like this because I scaled it, so I'm going to go ahead and turn off Pocket. Pocket only. Slice it. Now it should do it. So for some reason when I scale it doesn't like Pocket. But anyway, it's doing, you can see it's doing these little meshes right here. And then it's roughing on the top. And I can, it's facing on the top. I can turn off facing over here. And then I can go ahead and slice it again. And it's hard to tell, but it's no longer doing the facing. So I've got that. And it works pretty good. Not bad for a web interface. My goal is to get everything so it's web interface. This is one of the torture tests I generated with it a while ago. And it just shows some of the features that this has. So I can move my gantry around. I'll go ahead and unlock it. And then I can move it here. I've also got keyboard inputs, so I can, and I can increase the steps. So I can do, let's go ahead and increase that to 20. And it thinks it's home right now. I'm going to go ahead and home it. Oh, reset, unlock. Oh. Okay, reset. There we go. Take this out. So it's controlling all of this over with the Raspberry Pi. So if I like lose network connectivity, it doesn't change anything for me. It still cuts. I don't get to preview, but it still cuts, and it will finish out the design because it's all cached onto this Raspberry Pi. So as long as I've sent it there, and I can still pause and play and reset and e-stop all from the unit here, all enclosed, and it's completely independent from this. So if I run a job, like if I were to start running this job and just walk away and let my computer die or close it or whatever, as long as this sustains power, then it's good to go. Which is why I like this CNC JS. It's been really good. I've done quite a few jobs. It's been really reliable. I've also got spindle control set up, and I had to do a few tricks with the current version, which is 1.6.8. So if I load my settings right now, I'll scroll through these. So there should be my inline. Let's go ahead and load. Get all my parameters. Okay. Start blocks. Okay, so I had to set my spindle startup block here, so this sets the spindle speed. And I've got the spindle off on the spindle right now. And I've got the relay box off too. So I'll go ahead and turn the relay off, or relay on. And I'll go ahead and turn on and off the spindle. So I've got spindle control over here. And if you heard that, and I'm just for sake of it. So I've got it on over here, so the spindle will click on and you'll hear it. So I'm going to go ahead and click start. So it controls it, and when I run the G code, and I don't want to run it right now because I really don't want to crash anything. When I run the G code, it will turn on the spindle and then turn off the spindle as predicted, as long as it's in the G code. So sometimes you'll have to set a first and last line, or turn on the spindle, then run the job, and then the last line of the code, just make sure that you've added, or it was added, to turn off the spindle and you're good to go. Otherwise, you just manually turn it off here, there, and whenever you're changing the bit, I usually turn off the relay because I can see the red lights and it doesn't put as much wear on this switch on the spindle. But yeah, and this, as far as this relay goes, it's wired in. There's 2 screws that are on the board, on the power supply, that supply power to the entire Gerbil shield. So I'm screwed onto those screw terminals that are on the power supply. So that's where I'm getting the 24 volts. It's down under the Gerbil shield right now, directly to the power supply. So I'm just feeded on to, there's actually extra screw terminals, and I'm just using, there were 3 negative and 3 positive, and the shield's only using one of those sets. So there's 2 other sets, and one of the sets just goes to this and powers this. So it's all enclosed, it stays really cool. It's got plenty of power. I think this will do 4 amps. Yeah, and it's nice smooth current. You've got to dial it in with a voltmeter beforehand, and then you're good to go. And as far as getting this set up with CNCJS, I've written in their wiki how to do everything. So if you just go to installation Raspberry Pi setup, it mentions Kirimoto in here, how to do all the setup. There's a few things that aren't in here that I may add later, like my little login script that does Xcarve. Hell, I'll just go ahead and show you real quick what that looks like. So here's that. Let's go ahead and open recent. Oh, and here's the shutdown button. So it's just a standard Python script. I create the script, and then I have it working here. And I'll try and post this, but I'll go ahead and record it because there are never any promises. And then I have this auto start option 1 running as a cron job, and it just does, you know, at reboot, when it starts up, it'll start up the script, and then it puts out the logs for any of it. So when you start up, the at reboot basically is when you reboot the Pi, or when you start up the Pi, it'll run that cron job. And so it runs as soon as you start up, and it just waits there, depending on which script, which I've gotten this top one working. Then it'll either wait for an interrupt or just wait for a pin to be detected. And the other cool thing is, so the pin I've got it wired to, which is GPIO 3, I believe, set as 5 on the board. This is set to the true pin numbers. So yeah, it's 5, so that's the actual. So it's this first red one. Sorry though. So that's how I've got everything wired in. So this, on this side, this red one and this blue one, which are spaced. It's hard to tell, but they're spaced kind of apart. I'm sorry for the terrible image quality. but there is a space between this blue and this red right here. And this black and this red back here, these two silicone wires that aren't twisted, those are for power, these are for the interrupt. And whenever you turn off the Pi, like if you accidentally bumped it, you don't have to power down the entire unit. You bump it again, or you just leave this on and you turn that off. Just hit it. I don't recommend it, but this will basically turn it back on again, as long as it has power. So usually I'll hit this, wait about 30 seconds, and then turn off the X controller, and it will safely shut down the Raspberry Pi and this. So another alternative would be to put in a big capacitor bank, and whenever you lost power, the capacitor bank would give it enough time to shut down the Pi, and it would trigger that shutdown sequence to like drop that pin. But I haven't set that up. This is fine. And I usually am able to quickly log into it anyway, so a lot of times I'll just come in here and I'll do sudo shutdown. And that does just fine for shutting down the Pi. So I usually I can do it either way. Anyway, so that's how I've got things set up. I really like it. The Raspberry Pi is fairly inexpensive, and really all the components here, maybe $60 for additional components, plus some smaller stuff I had laying around, which actually I have this laying around. These run about $5 to $10. The case was $10. Raspberry Pi was like $35 or $40, and then the X controller. So that's what I've got set up for my X-Carve, and I just wanted to share because it's a good setup. It's taken a little while to research. And this right here is a IoT relay board made by a fantastic company, which I cannot remember the name of. But if you search IoT relay, you'll find this board, and it's phenomenal. It allows you to set plugs for normally on and normally off. So everything I have is normally on, but if I say wanted lights to go out or something to click off, I have a lot of options. I just can't say anything else good about the board. It does feel a little inexpensive, but it seems reliable. It seems pretty well built, and it allows me to kick on my router and my little shop vac, and all from here. So it works out pretty well. Anyway, this will probably run a little bit long, but oh yeah, I was going to show you the profile. So here's the profile script. Top does updates. Then I've got this X-Carve, which this is from the guys at Adafruit. They built a little wireless Inventables easel, just wireless easel access, and that they put that together, and I'm borrowing it from them just to put in because I like the aesthetics of it in my system. So I put that in there for me, just to kind of enjoy. And then I've got this kind of auto login, so when I log in, it'll run screen, which is nice and lightweight, and we'll pop in a screen session. So if I lose connectivity and I'm running updates, it's not the end of the world. The updates should run, and I can reconnect to the screen session if I need to. Yeah, so this is my X-Carve with a Raspberry Pi. It's really great, and if you guys have any questions, just reply back to the post on the forum, or message me on YouTube, and I'll try to get back to you. I hope you enjoy. Thumbs up if you do. Thank you much.